Here we've got one of the core sections which has been drilled on the Lomonosov Ridge during the Arctic coring expedition.
This is a true treasure of the deep, worth its weight in gold. A time capsule that holds secrets from the past, vital to the future. Its story is a story of skill, dedication, and scientific excellence, and of voyages of discovery to some of the most demanding places in the world.
Fantastic experience.
Very complex.
An astonishing achievement.
Very draining.
The voyage of discovery.
Some of the best scientists in the world.
It's an international family.
An enormous team effort.
That's what it's all about.
If we want to really understand what we are doing to our planet,
we need answers.
We need to understand how it worked in the past.
To urgent questions.
A car park at Bremen University in Germany.
This is the container I actually spent about 5 weeks in. Yeah, 5 weeks, 3 to 5 persons, sometimes at one time. I really like it. I like to work in these kind of environments.
For geochemist Lucy Schneiders, this cramped space is a reminder of one of the very best times of her professional life. An expedition to a part of the world most of us will never see. In 2004, a voyage into unknown waters for Lucy and for geology in the Arctic Ocean.
Very crowded, very loud and very cold, of course.
The mission to drill down into the seabed below the Arctic ice and bring back a series of cores for geoscientists all over the world to analyse. The first time anyone had ever attempted Arctic seabed drilling on this scale, and one of the most technically demanding seabed drilling projects ever undertaken.
The main problem up there was coping with the ice flows, and the ice tended to push the drill vessel off position.
You really have to break these big ice floes apart in order to make it possible for the drill ship to keep station.
Take one of these ice-breaking vessels and punch a hole through the middle of it. Build a drilling rig on top of that.
With 2 other icebreakers, and these 2 vessels together worked to clear the ice so that the drill ship could remain on station.
It was a completely new concept of how to do this.
In the end, we came back with over 600 metres of core. One of the most exciting findings was that the Arctic used to be ice-free. Very high sea surface temperatures, up to 24 degrees.
All the seaways were closed, and that means that we nearly had freshwater conditions. Normally, it's hard to find those places from a totally different environment through the process of changing into an environment you find today.
History that's stored within those cores, it is the only record that goes back that period of time, back to 55 million years. So yes, the cores are extremely valuable.
It worked out extremely well.
I think that the expedition was a tremendous scientific success.
A success and a great start for a new name. Ecord was born in 2003. A scientific consortium of 16 European countries and Canada formed to support the work of the global IODP project.
IODP contributes to the understanding of how the Earth functions, and IODP does it by providing data collected from the subsea floor using drill ships and drilling platforms.
Ecord's contribution to bridge a gap in the work of the IODP.
The Americans had a drill ship and it went round the world drilling where it could. They'd realised that they couldn't use that ship in shallow waters or in the Arctic where there's lots of ice. Difficult conditions. The ship was too big to get there, it couldn't cope with the ice. So the Europeans came up with the idea of chartering different vessels that could go to those areas and take samples where they couldn't go before.
So the mission-specific platform expeditions were born. The Arctic was the first, and the start of a cross-border collaboration that successfully spans Europe.
We've really brought together experts from across Europe.
We are taking advantage of existing expertise in different places.
So BGS here in Edinburgh provides the contractual work and the drilling expertise.
It's my role to see what is possible technically, what sort of water depths are the scientists trying to work in, what is it they're trying to achieve. Then look at all the options, what sort of platforms you can use, what sort of vessels and ships, and all the logistics associated with running that operation.
Our colleagues at Bremen University have the onshore storage for the cores.
Bremen has this magnificent core repository. They have the know-how on how to deal with cores.
It's a big treasure for our university. One of our focus is to work on reconstruction of the climate in the past. You can read in the seafloor like turning pages of a book and therefore know how the temperature, the climate did change in the past. We need to make an effort to predict the climate for the future.
When we drill the holes, we don't just core the sediments, we also lower things down the hole to measure physical properties in the hole. So we've got our partners from Leicester University and Montpellier in the south of France to lead on that one.
The downhole logging is important for several reasons. It's the only measurement that's providing you the actually on the site, in situ measurement of the borehole conditions. You'll be able to match your core to your downhole logs, so it'll place that whole succession in a context.
A fantastic opportunity to work with other scientists, some of who are really at the top of their field.
There's knowledge exchange in terms of the science and there's knowledge exchange in terms of the technology, and you can't put a price on that really.
Geoscience without frontiers. It's one of Ecord's major strengths.
I think Europe has a very strong scientific impact on the program.
If you look at the scientific contributions and the achievements that we've done, I think we more than hold our own.
And the key is the rolling programme of mission-specific platforms, or MSPs, because the Arctic was only the beginning. So a year after the ice, a complete contrast in Tahiti.
I couldn't believe it within the first days that I was offshore just doing the project. It was just a dream.
In Tahiti, the aim wasn't to go back millions of years, but to our more immediate past. Locked in the fossilized coral below the seabed, a time-lapse recording of sea level changes towards the end of the last ice age, some 10 to 20,000 years ago.
Corals, they grow like trees. They have annual growing rings. If the sea level is down, the corals will die. And as soon as the sea level is rising again, the corals start growing again. So we have different sequences of corals and non-coral.
Vital data to help predict sea level changes in our near future. But retrieving it posed brand new challenges.
Tahiti was very different from the Arctic. For a start, it was a lot warmer.
Heat was one of the problems or challenges.
Noisy, it's smelly.
Rain, heavy tropical rain.
We were working 24 hours a day for 6 weeks, a mile from the shore, and we never once came into port.
But nothing got in the way of making the expedition a success.
We got more than 600 meters of corals with a very impressive recovery of coral reef records.
And all the time, they were working in one of the most fragile environments on Earth.
We wanted to avoid any impact on this very sensitive coral reef ecosystem. That's why we always use a camera.
We load a downhole camera down the drill string and observe the seafloor.
Just to make sure that we didn't impact at all.
If there wasn't a live coral, we would then lower the drill string to the seabed and start coring.
A system Ecord refined on the Great Barrier Reef, the companion MSP to Tahiti, in 2010. A remote submarine camera explored the reef looking for safe seabed and then helped direct the drilling, sending back some fascinating images in the process. The Great Barrier Reef expedition had the same aims and the same results as Tahiti, bringing to the surface cores filled with ancient corals, some still as spectacular as when they were alive thousands of years ago. Together, these two MSPs represent a powerful data set.
The results from Tahiti and the results from Great Barrier Reef should complement each other, and we should be able to get a very good record of sea level rise.
It's not finished yet, because there are still hundreds of thousands of measurements to be made.
It's a unique data set which allows you to understand how the seawater level raised during the last deglaciation.
Although the number of scientists who are involved offshore is limited, the number of scientists who can use the data is limitless.
Ecord has carried out one other MSP so far. Sandwiched in between Tahiti and Australia was a trip to the North American coast, the New Jersey shallow shelf. This time drilling back in time not 20,000 years, but 20 million.
And why did the scientists want to do that? They wanted to look at how climate had changed and how the sedimentary pattern had changed and how sea level had changed along that Atlantic coast.
This was different because it was not a ship. The first time we were working on a lift boat.
It was a stable platform, it didn't move, which made it more comfortable to live on. You didn't have the constant swell keeping you awake at night.
But on the other hand, it was the smallest ship or platform we ever worked on.
Ecord was a very small vessel, but the crew were fantastic, and I don't know, it was a really good atmosphere.
The result? Nearly 2,000 metres of core to add to the impressive archive in Bremen.
We've got a fantastic legacy for scientists coming on. Time and again, people go back to the core because new ideas evolve and they think, well, I could test that using this IODP core or that ODP core. So in a way, the possibilities are endless, or almost infinite, for the science that we can do with the core we recover and the data we generate.
A meeting at Ecord headquarters in Paris in February 2011. Around the table, a group of independent scientific assessors brought together to measure the achievements of Ecord over the past 7 years. Their findings will be read by governments across Europe.
I think it's fantastic that so many nations can work together on a voluntary basis and really participate both scientifically and technically.
I'm impressed by the way in which they have come up with a remarkable variety of new evidence, given that the difficult situations that they've been working.
One can be proud of the results up to now.
And Ecord is proud, but more than that, for everyone involved, it's a lot more than just a job.
You go to sea, you sail together, you spend 1 month, 2 months together on a ship with the same single aim. So it developed real ties.
One of the luckiest times in my life.
It's really pushed me and challenged me.
I feel very lucky doing this kind of work.
It's just opened my research up.
Ocean drilling is pure science.
If you look at all the scientific results that have come out of this, it gives us a huge sense of achievement.
I think it's important for everybody.
As the program continues, I think we are getting better and better.
We've learned a lot during these expeditions.
No one else on Earth has the expertise we have.
It's quite a big buzz to have brought it all together.
It's a great challenge.
Just the feeling that you were capable to do that.
It's also a big satisfaction.
Without this technology, without this capability of operations, then this science would not be able to be achieved.
It's unique material, it's brand new, it's fantastic.
You need to drill in the ocean, and we need a lot of more material.
We use satellites, we look at other planets and so on, but we still don't fully understand the planet that we live on.
I'm looking forward for the next expedition, wherever it is.